Back in the day, I used to love physics. That's until topics like circuits started to scare me, make me a little nervous. So if you're a little bit nervous about circuits, I'm here to make it a little simpler for you. So in your physics textbook, you probably saw something like that looked something like this with some lines going on here, and then another thing with a circle and a little arrow, and then you got something here, and then like some squigglies, and then some more squigglies, and I'm doing a really bad job here, but you got the point. Like you've seen something like this, and you're like, whoa, ho, ho, what is happening here? Like what are these things? So I'm going to take my eraser, and for now, I'm going to get rid of those symbols, and we're going to actually use a picture of a cartoon battery and pictures, actual pictures of real things. Okay, so in a circuit, a voltage needs to be supplied. So our voltage supply will be our battery. We've all seen these things here. We've all used them many, many, many times, over and over. All right, so that is what's going to supply our voltage. So let's move that into a convenient place. All right, seems convenient enough. All right, now, in addition to the battery in our circuit, we need something here that requires a current, right? Like it could be a light bulb, it could be a telephone, it could be anything that requires a current. In this case, I have a picture of something called an ammeter, and that just measures the current. So again, our ammeter could be replaced with a light bulb or whatever else that needs a current. So let's keep that right here. Now this cute little guy right here is called a resistor. We probably haven't handled too many resistors, if any at all. But what a resistor does is it's kind of like a bodyguard in a sense. It like holds back who needs to be held back and pushes forward who needs to be pushed forward. Not really, but in a sense, yes. What it does is it allows the right amount of current to reach this thing. Whether this is a light bulb or just an ammeter, it allows the right amount of current to reach. So let's move it closer so it can be a part of our circuit. Now, so in our circuit, we would take wires and we would join the battery to the resistor, and then join the resistor to the ammeter with wires, and then close it up and join that back to the battery. And ideally, in an ideal case where an experiment is going fantastically well, you would see our ammeter needle go doing, doing, doing. It wouldn't make the sound, but you would see that current reaches the ammeter. Now, how much current reaches the ammeter? Well, a smart guy called Ohms figured out that the voltage will always be equal to the current, which we call I, times the resistance. Let's actually write down what these things are so we don't forget. Voltage for V, current I. Who knows why current is I, but it is. Come on, let's see, there we go. And R is resistance. Okay. So we have voltage equals current times resistance. So for example, if this were a 3-volt battery, and our ammeter, we only wanted, let's say, 0.5 amps to reach the ammeter, then in order to figure out what size resistor we would need here, we could plug into what is called Ohm's law. So this is actually called Ohm's law. So let's make sure you know that. So we could plug into Ohm's law, which is again V equals I times R. So our voltage of 3 is equal to the current, which is 0.5, times R. In order to figure out the resistance that we need, all we'd have to do is solve our equation. So we would divide both sides by 0.5. And we would get that the resistance needed is equal to 6. So here, this would be 6, and our units is ohms. Let's take it a step further and see how more than one resistor would work in a series. Okay, so for convenience sake, let's say we still have the same battery, which is 3 volts, and we still have the same requirements of 0.5 amps here, which means that we're still going to need a resistance overall of 6 ohms. Now, These resistors are said to be in a series. One just comes right after the other. So they're in a series. When we have more than one resistor in a series, it's nice and straightforward. The sum of the resistance, so let's say R1 plus R2, in this case this would be R1, this would be R2, but it could be any amount, so let's say up to Rn, will be equal to the total resistance. So let's say that you are told that R1 and R2 or two resistors are the same. In this case, each resistor would have to be 3 ohms because it has to add up to 6 ohms. So again, nice and straightforward. Now, wouldn't it be easy if every circuit just had parallel resistors and all we had to do was add and subtract? But of course, life is not usually always that easy. So here we have another circuit. It's a little bit more complicated. So we do have one resistor in a series here, but over here, this set of resistors is called parallel resistors. So this is in series with this whole set, but when you get to this set, they are parallel to each other. Let's talk about what that means and actually look at an example here. All right, again, for convenience sake, our battery is a 3-volt battery and we need 0.5 amps. So as we already know, because we already calculated it, our total resistance for all 3 of these resistors has to be equal to 6. So let's write that down. Our total will be 6. Now, let's call this RS for series resistor, and let's call this RP for parallel resistor. All right, so our total resistance would have to be equal to RS plus RP. So far, not so bad. All right, let's say I told you that the resistance for this is 1.5 ohms. So our RS is 1.5 ohms, and we know that our total is 6 ohms, which means that our RP would have to be equal to, when you solve, it would be 4.5 ohms. All right, so far, hopefully you're following me. All right, now, unfortunately, we can't just take that 4.5 and divide it into 2 because they're 2 resistors. No, because those resistors are splitting the resistance. So there is another way to figure out how that 4.5 is distributed. Here's the rule. 1 over the resistance of the parallel resistors is equal to 1 over one of those resistors plus 1 over the other resistor. In this case, there are only 2. But if there were more than 2, we could go ahead and add all of them up in this way. Here is where the math comes in. So as you can see, we're dealing with not just regular sums anymore. We're dealing with sums of the reciprocals. So we have to be able to work with these rational numbers. All right, so let's take a look at how we would go about doing this. And again, for convenience sake, let's just assume that these 2 resistors, right here and right here, are of the same size. So we can say the resistance of each one is X ohms. It's not the same as this guy right here, or it might be, who knows, we'll figure it out. But they're definitely the same as each other. So we know that 1 over 4.5 will have to be 1 over X plus 1 over X. Now again, where did I get that 4.5 from? That's right, we knew it from up here. Okay, so going ahead and solving for X, we have 1 over 4.5 equals, our common denominator is X, fortunately, in this case, 1 plus 1, so that's 2 over X. So we have here that 1 over 4.5 equals 2 over x. We can go ahead and cross multiply, and we get that x is equal to 9 ohms. Okay, so I hope I've successfully managed to demystify simple circuits for you, and you actually find simple circuits to be simple now. Have a great day.